Hello everyone and welcome back to the Kohi game engine series. Today we are going to be tackling a camera system. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier of support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. So camera system is another one of those things that we really are going to need for our upcoming view system. And for now, we're just going to sort of put in the bare minimum that we need to put in for a camera to get it sort of working properly, but it'll also allow us to remove a little bit of the hacks that are in the system. So this video shouldn't take very long at all. This is going to be a pretty quick one, I think, because cameras, at least on the surface, are not too complicated. So we're going to be expanding this system most definitely as time continues. So it's going to start off pretty simple, but it's going to increase in complexity and features over time. Anyway, so the first thing that we're going to want to do is start by adding some files. So I'm going to go under renderer, and I think directly under renderer should be fine. So I'm going to create a new file here, and I'm going to call it camera.h. And the first thing that we're going to want is pragma1 and mathtypes.h. So I'm also going to slam a file comment in here. Obviously cameras are mostly math. They're actually a pretty straightforward structure though. So that structure looks a little bit something like this. It, for right now, only contains 3 properties. So we have the position of the camera, the rotation of the camera stored in Euler angles. So, no, Euler angles. Every time I read this, I always pronounce it wrong. It's supposed to be pronounced Euler. It's stored in Euler angles. So that's yaw, pitch, roll. And then we also have a view matrix. So I have notes in here to not update these things directly. Because we are going to be maintaining a isDirty state, similar to how we did with our transforms. And so updating these things directly will not update that flag unless you also happen to remember to update that flag. The idea behind that is that we only recalculate our view matrix when we absolutely need to. So as you may have guessed, we are going to have a pretty decent collection of functions here, starting off with a camera create and a camera reset. Camera create simply creates a camera and returns it, fills out this structure with some default values. Reset resets the camera to default values. We don't really have a destroy, at least not yet, because the camera doesn't really hold any non-stack sort of resources. We don't have any dynamic allocation happening from cameras. So at least for now, we don't have a destroy. So the next thing that we're going to have is we're going to have a getter and a setter for our position, because again, we want to manage everything through this, not the direct properties themselves, because we want to handle that dirty flag. The same is going to be true for the Euler angles. So we have our get and set for the Euler angles as well. Looks like I missed a thing there. And then, of course, we have a getter for our view matrix. Now, this returns a copy of the view matrix, and so it does not allow us to set that matrix. We may want to eventually allow for that, but for right now, I don't really see the need for it. If you use these other properties, whenever you go ahead and retrieve this, it will recalculate it if need be. So because that performs a recalculation, that is why we are not using a constant pointer here like we are on the other getters here, because it can potentially update the data in the camera. I.e. the dirty flag and the view matrix. Okay, so the next thing that we want to add is we want to add some basic movement functions. because that's basically the most basic idea of a camera, is that you should be able to move it around. And so we don't want to constantly be having to calculate the direction vectors and all that stuff. We want to just be able to say move forward, backward, left, right, up, or down. And for now, up and down are purely going to be on the y-axis because we only have one camera mode that's sort of a free mouse look camera mode. As we increase the features of this, that's probably going to be changing, but for now, that's how that's going to work. And then we also have the ability to adjust the yaw and the pitch of the camera by a specified amount. So this is not a setter, it adds the amount. So if you pass a positive value, it rotates one way. You pass a negative value, it rotates the opposite direction. So we have yaw, pitch, and pitch here. We do not have roll. And that is because we are using Euler angles for this camera mode. We don't want to wind up with a gimbal lock situation. So in this case, we don't want to wind up with that. So we are eventually going to have cameras that use quaternions instead. But for right now, pitch, yaw, roll is the easy way to go. So that's what we are going to do. And that is our entire camera interface. There's not a whole heck of a lot to it. It's relatively simple. So most of what I'm going to do in this video, at least for the camera stuff itself, is I'm going to be just pasting a lot of stuff because it doesn't really require a whole heck of a lot of explanation or debugging. So the next thing I need to do is create a new file under renderer. We're going to call this camera.c. And we're going to, of course, include our camera H and our kmath because we're going to need some math functions. So our camera creates a camera, resets it, and returns the camera. Reset is what actually performs the setting of the default values. So for the Euler rotation, it sets everything to 0. For the position, it sets everything to 0. IsDirty is set to false by default, and it uses an identity matrix by default. Because an identity matrix winds up lining up with a 0 rotation, 0 position. So there's no need to regenerate this right off the bat since everything is defaulted to 0. One thing I should note as well is cameras do not have a scale like a transformation does. And that's because that doesn't really make sense, because it's literally a perspective from a point in space. So there is no sense in adding any sort of logic there for scale. Next are getters and setters. So our camera position get makes sure that there's a camera pointer first and then returns the position of that. Otherwise, it returns vector 3, 0. This is to prevent crashes. The setter basically makes sure we have a pointer first, sets the position to the one that's passed in, and then sets the dirty flag to true. The getter and setter for the Euler angles works exactly the same way. So to get that, we return a vector 3 if we have a camera pointer. Otherwise, we return a vector 3, 0. And the setter just checks to make sure we have it, sets the rotation, and flips the flag dirty to true. The next, probably most important function in here is the view get. So all this does is it makes sure that we have a pointer. If that pointer is dirty, then it goes ahead and calculates a rotation matrix based off of the Euler angles. It calculates a translation matrix based off of the position. It multiplies those things together, creates a matrix by inverting that matrix, and then flips the isDirty flag back to false. If it is not dirty, it simply returns the view matrix. So either way, it returns the view matrix. It just does this logic first if it's dirty. If for some reason we don't have a camera pointer, this returns matrix for identity, so that, again, we don't crash. All right, so next is the directional movement. So I'm going to go ahead and put them all in here at once because they're all basically the same. It's just for different directions. So our forward basically takes the view matrix from the camera. So it goes ahead and uses that get to make sure it's up to date, and then calculates matrix for forward off of that matrix and returns it. Otherwise, it returns a 0 matrix. We could technically make this like 1, 0, 0 or something like that if we wanted to, but I want to sort of return a 0 matrix so that if for some reason we can't move our camera and we get a 0 matrix, it helps kind of make it obvious as to why. Backward does the same thing. It just calls mat4 backward. Left, right do the same thing, just calling the matrix functions as appropriate. So all those things are pretty straightforward, I think. Move forward basically takes an amount. So if we have the camera, we calculate a direction vector by getting the forward vector of the camera. We then go ahead and multiply that direction vector by the amount by multiplying a scalar. And then we set the position by adding to the current position the direction. Technically, this could be considered velocity instead. And then we go ahead and set is dirty to true. That way, next time we get the matrix, we go ahead and recalculate that. So we do the same thing for backward and left. And then also, I forgot to actually put in here the right movement. So we have the right movement. It just uses camera right. And then we also have our move up and move down. And these are the ones that are a little bit different. So in the case of move up, we get the vector 3 up, not the camera up. Because if we're pitched forward, then the up would technically be up and forward into space, not straight up. And that's not necessarily what we always want with a mouse look camera. Usually when you want up, you want straight up with a mouse look camera. So again, we'll be changing these things depending on the various camera modes that we eventually implement. But for right now, this is the implementation that we have to keep things simple and get us up and running. So we get the direction, but then everything else is basically the same. We multiply scalar amount, which is the amount here, by the direction, add that direction to the position, and then set the dirty flag to true. Down is the exact same, except we use vector 3 down instead of vector 3 up. It's the only difference. Okay, so yaw and pitch are pretty straightforward and simple as well. So yaw basically just adds the amount that's passed in. Again, that can be positive or negative to the y-axis's rotation, and then flips the dirty flag. The X is a little bit more complicated because we have to do something to avoid gimbal lock. And gimbal lock is something I've talked about a little bit on this channel before. If you guys are wondering what that is, feel free to look that up. But basically, it's where you lose an axis of rotation, and it basically causes two of the axes to collapse onto each other. And so you wind up losing control. So we avoid that in our case by clamping the Euler's X rotation. So the first thing we do is we add the amount to the rotation X, but then we also say we want to clamp this to 89 degrees of rotation up and down. And so this is the sort of static constant for that, which is basically the equivalent of calling deg to rad 89.0f. If you were to call that, you'd get the same thing. So this just gives us that in radians. And then says we want to clamp that value. So we want to clamp rotation x to the negative of that and the positive of that. And then we go ahead and set it to that. And that's just to avoid that gimbal lock situation. And then we go ahead and flip the dirty flag to true. And that's it. That is our entire camera structure. So there's not a whole lot to it. It's mostly comments on the front end, honestly. So the next thing that we want to go ahead and do is we probably should go ahead and set up our camera system for this, because that is something that we are going to want to use instead of just creating cameras willy-nilly. And the reason for that is because we're going to want to have the concept of an active camera that should be used within a scene for rendering, for example. And to do that, we need something to manage our state. So it makes sense that we have a camera system to do that for us. So the camera system is going to be pretty straightforward. There's not a whole heck of a lot to it, but let's go ahead and jump into that. So under systems, I'm going to go ahead and create a new file, and we're going to call this camera system.h. And we'll go ahead and pragma once and include renderer camera h. And I'll go ahead and throw a file comment in there as well. I'll fill that out in a bit. In fact, actually, the camera system is responsible for managing cameras through, I can't type today, the system engine. There. Okay, so we have that. As with every system, we need a config struct for it. So in this case, it's just going to be a max camera count. So it's the maximum number of cameras that can be managed by the system. Is the only thing we're going to have there. We're going to have a default camera name because we want the ability to get cameras by name. So we have to have a default name for that. We're going to have a camera system initialize, which just like every other system takes a memory requirement, state, and config. That'll work the exact same as what we have seen before. Obviously, we have a shutdown. That also works the same as before. With this, we also have an acquire and release. So the camera system acquire just takes in the name of a camera. If one does not exist, it goes ahead and creates and returns it. If one does exist, it returns a pointer to that. And release releases a camera with a given name. If the counter reaches 0, the camera is reset, and the reference is usable by a new camera, so it's not counted as in use anymore. And then, of course, we also will have the concept of a default camera. And this is going to be very useful for us when we go to actually start setting up our views. So that just returns a camera pointer to the default camera that we're going to set up in the system. So that is everything in terms of our interface for our camera system. So as you might have guessed, our camera system itself is not going to be very complicated because there's not a whole heck of a lot that it does. So we're going to create a new file, call it camera system.c. And we're going to start at the very top with a bunch of includes. So we are going to need, obviously, camera system. We're going to need our logger. We're going to need some string handling because we're dealing with names. We're going to need our hash table, and we're going to need our camera.h. So we're going to need all those things. And we are going to have a struct lookup for cameras, to hold our cameras, right? So that just is a ID, a reference count to that camera, and obviously the camera itself. Next, we're going to have our system state, which looks a lot like the other system states that we've seen before. So this is going to hold a copy of our config, our hash table, and the block of memory for that, a array of camera lookups, and then a default camera that is not registered, but that always exists as a fallback just in case we need it for some reason. Just like the other systems, we are going to have a state pointer, which is the camera state. And then our initialize is pretty much going to look exactly like what we've seen in other systems. So I'm actually just going to paste this in because, again, we don't really need to review this in depth. We have our struct requirement, our array requirement, and our hash table requirement, which gives us our memory requirement. And then, of course, if we have not passed state here, that means we're just getting the memory requirement, so we return true. Next, otherwise, we set the state pointer, we set our array block, our hash table block, we create our hash table, fill it with invalid IDs, and then invalidate all cameras in the array by setting their IDs to invalid ID and setting their reference counts to 0. And then we actually we're setting our state pointer again. We actually don't need to do that. And we can actually move this up here. So we'll keep a copy of our config. And then we go ahead and set up our default camera by just calling camera create and setting our default camera to that. And that's it. Our shutdown is really simple. I have stubbed out some stuff in here. So if our cameras ever take any sort of resources or there's some sort of dynamic allocation that needs to be freed, we could certainly add a free in here, and we've already got the loop set up for it. So we don't really need to do that now. I've just set this up just in case we need it in the future. So our acquire works a lot like our texture acquire. So again, I'm just going to sort of paste this in here. So we take a name, first thing, if we do not have a state pointer, then we return a null pointer after bleating about it. The next thing we do is we say, okay, well, is the name equal to our default? This should probably be default camera name, actually. So if it's equal, then we're just going to go ahead and return the address of the default camera, which gives us our pointer. Next, we're going to look up in the hash table, say if we have if we have a array, if we fail that lookup for some reason, which is not the same as it not being found, then we need to go ahead and error. So we try to look it up first, and then we say, hey, if the ID is invalid, then we have we don't have a camera, so we find a free slot, stand that up. If we find a free slot, we stand it up. And then, of course, once we have that here, we just increase its reference count and return the address of it. So pretty straightforward stuff there. All right, and next we have our release. So our release basically just does exactly what you would expect. So if it is equal to default, which this should be default camera name, then we cannot release the default camera and we just boot out. Otherwise, if it fails the lookup, we bleat about that. That should really never happen, but if it happens, we'll notify about it. And then if the ID is not invalid, then we go ahead and decrement its reference count. If its reference count is less than 1, then we go ahead and reset it, set its ID to invalid ID, and then update the hash table with that. So finally, last but not least, is we just have our default, our camera system get default. So if we have the state pointer, we just return the address of state pointer default camera. Otherwise, we bleat about it and say, hey, you've called this before the system is initialized, and return null. And that is it for the camera system. There's not a whole heck of a lot going on in here. So that's why I just kind of blazed through it really quickly, because there's not really much point in, looking at it any further in depth than that. So probably the next thing that we should do is, and we should probably initialize our system first. So let's go ahead and do that. So we'll go to application.c, go all the way to the top here, and we will add a memory requirement and a system state. Let's go ahead and do that here. So that we have that, we're also going to need to include our camera system. I should do that before I forget. So let's put that with the other systems here. Okay. And then all we're going to do is basically call our initialization. So this is going to wind up being basically right after our geometry system. So let's find that. So right here. And all we're going to do is create our configuration. So our max camera count, in this case, we're just going to set it to 61 because that's a prime number. We are going to initialize our system, get our memory requirement, allocate our memory, and then really initialize our system for reals. And then we are set up to use our camera system. And that is actually everything we need to do from the application. So now we have everything stood up to actually use, to be able to access our camera system. So let's actually put some stuff into place for us to actually be able to use it. So I think the first thing that we should probably do is go to renderer frontend .h, and we're going to have a set view, which has been sort of a hack, right? We said a long time ago this should not be exposed outside the engine, and that is absolutely true. So we are going to finally get rid of this hack. It's gone. And we are going to go to the implementation of that front end. And let's see, that was called set view. And we're going to nuke that as well, because we no longer need that rubbish. So instead, we're going to use our new camera system. So we're going to include systems camera system. And we're going to come to our system state, and we're going to get rid of the view matrix here because we're not going to have a hard-coded one of those either. And also our view position, that's going to be gone as well. And instead, what we're going to do is right up here at the top, we are going to have a camera, if I can type, pointer, and we're going to call this active world camera. And we're going to keep a pointer to a camera here. And so this means that we're going to have a couple of errors pop up in our code. So down here, we have our configurable camera starting position, which ultimately wasn't even really being used anyways. So we're going to go ahead and nuke that because that doesn't make sense anymore. We don't have that. We're going to come a little bit further down, and within our draw frame, we are going to, let's see, right about here, right before we actually begin the frame, we're going to say if we don't have state pointer active world camera. So if we don't have one of those yet, which we won't the first time we run, we're going to say just grab the default camera. So we can say state pointer active world camera equals camera system get default. Right? And the next thing we'll want to do is we'll want to calculate our view here. So we'll say mat4 view, and we'll want to take a copy of that. So we'll say camera view get, and here we will pass the state pointer active. Why can I not? I can't type today for some reason, or any day it seems like lately. Active world camera. Why is this? Oh, because I forgot an equal sign here. No wonder the IntelliSense isn't working. Okay. So we'll go ahead and get our view matrix here, which will either be already created or not. The first time we run through it won't be, but after that it should be, unless we change perspectives. So the next thing, we're going to have a couple of errors that we need to fix here. So we have our begin render pass, and then we have our material system apply global, which is looking at state pointer view. So all we're going to do here is pass the address of view now, because we no longer have that. We also have the view position. So instead of that, we are actually going to wind up passing the state pointer active world camera position. Now, typically, you don't ever want to update position directly, but you definitely can get it directly. There's no need to make that function call. It's just there for consistency. So in this case, we're just going to use the property directly because we're not going to be modifying it in any way. We just want to pass through the position directly. Okay, and I think we already got rid of set view, so I think that should be everything that we need to do in the renderer front end. So now the renderer front end is actually set up to use this camera system the way that we intended. So the last piece of this is actually going to be to update our game, which is actually, believe it or not, where most of the logic actually takes place, or most of the logic is actually going to get nuked. So I think I'm going to actually start in the H file because it has a few less changes. So here we want to include our systems, camera system. And that will give us everything that we need. And then instead of all of this view, camera position, camera oiler, camera view dirty, all this crap, this all can go away. And we could just say camera pointer, and we'll call this world camera. And so we're going to store a pointer to a camera in our game state. So the next thing is we're going to want our game. And of course, this is riddled with errors because there's a whole bunch of stuff in here that we now no longer need and need to delete. So first thing is we do not need the renderer front end anymore. So goodbye to that. That hack is gone. We can get rid of recalculate view matrix, camera yaw, camera pitch. We do not need those things anymore because the camera system will handle that for us. as far as that goes, we do need to include renderer types INL. So we do need to include that. And what we're going to do is, instead of all this poop here, we are going to say state world camera equals camera system get default. And then we're going to go ahead and set our camera position to what we had here before. So I was actually a little bit too quick in nuking that. So let me actually copy this and redo. And now we can say state world camera set, oops, camera position set, not get. Then we need state world camera, and then we can pass the position. So that way we still have our correct starting position. The next thing that we're going to need to do is we have all these calls to camera yaw down here and camera vector forwards and all this other stuff. So we're actually going to need to adjust all of this stuff. So let me see here. We have, funny enough, our camera yaw function winds up being the same because our camera system, or our camera itself, also has a function called camera yaw. So instead of using the local one that we had here, now it's calling that one. The only thing that we need to do here is actually pass state world camera for these. So these updates are actually pretty straightforward. Those are fixed. And now for our movement, instead of calling or calculating all of this stuff in here, what we're actually going to do is we're going to get rid of the velocity. We're going to set a static const. So we only set this once. And our temp move speed, we'll leave that at 50. And we'll come down in here and get rid of these. And instead we'll say camera move forward. And this will take in our state and world camera. And then temp move speed times delta time. And so that's a lot cleaner of an interface to be able to work with. So I can copy this down here and say backward. Technically speaking, you could just multiply this by -1 and get the same result. But we might as well use the interface that we have set up here just to keep things nice and clean. So next we have our Q, which is going to be left. And then E is going to be right. Okay. And then we have our space, which is, instead of just setting the Y directly, we're going to say camera move up and camera move down. All right. And next we have all this stuff here where we're sort of calculating our view matrix and calling all that stuff and then setting the view. Goodbye. We don't need any of that stuff. That stuff is all gone. So the next thing that we'll need to change, though, is we have our temporary position code in here. This is calling state camera position X. So we're actually going to want to change this to, and I'm just going to change all 3 lines at once, world camera dot position dot XYZ. And that should give us all the changes that we need. Oh, it shouldn't be dot, it should be arrow. Okay, so that should be everything that we need. So let's go ahead and clean and build, just to be sure. And now when we run, we should have the exact same thing, but running through our new camera system. So this is the first step of our camera system. Like I said, we're going to be adding a lot more stuff to it as time continues. But, you know, we have to get something basic in there for our views. So that's going to do it for this video. This one was a lot shorter than the last one for sure. So that's going to do it. Thank you guys so much for watching. I appreciate all of you guys. And if you wouldn't mind hitting the like button, that helps me out a lot. If you have any questions or comments, please leave them in the comments below. And if you haven't already, consider subscribing. And I will see you guys next time.